Hello, this is Rick Powers coming to you from my home office for introductory statistics. And I am going to go through how to find the confidence interval for a proportion using our SALT software. So I'm going to share my screen here so you can see what I'm doing. All right, so the first thing that I want us to look at are these equations that we have for finding confidence intervals. You'll note that there are two. There's one for proportion, one for the mean. And what we're going to talk about right now is the proportion. What you see on here is relatively complicated, but I don't think it's necessary for you to know everything about how this works, because SALT will just take you through the process without having to use the actual formula. So the first thing is this p hat. P hat is the observed or the sample proportion. So if I go out and ask 100 people, have you watched a soccer game on YouTube, and find out just how many people have, and then I'll take the number of people divided by 100. That will give me my sample proportion. And then from that sample proportion, I'm going to add and subtract this thing. So that will give me an interval. And then that interval will give me an idea of where the population proportion would actually be. So what's included in here, as you can see, p hat is in both parts of this equation. Notice that n is down here. The larger my sample size, the smaller my interval is going to have to be. There's more accuracy with a larger sample size. And then we have this z critical value. And this is based on the idea of what we talked about. The binomial distribution is bell-shaped if I have a sample size which is large enough. And so then let's just say that this n was 300 instead of 100. And so then I'm just going to show you how you can find these critical values for z using SALT. Okay, so we go over here to SALT. We've got a normal distribution, mean of 0, standard deviation of 1. That means it's z-scores. Okay, and what we want is we want that interval to be in the middle of the distribution. So we're going to hit this between right here. And if I want a 95% confidence interval, then I'm going to put a 0.95 right here. Okay, so this is where 95% of my samples will be expected to be. And the z-score is negative 1.96 to positive 1.96. That's the idea of the plus versus the minus. So I find my number for my sample, and then I'm going to add, and I'm also going to subtract. That's going to give me the two ends of my interval. And in this case, that critical value would be 1.96. Now, I don't have to know this in order to use SALT for my confidence interval, because SALT already can figure that out. So let me show you how that works. In order to find the confidence interval for a situation, let's just say that I do a new example here. So let's say that I have a confidence interval, and I say 120 out of 300 people have seen a soccer game on YouTube. So then what is the confidence interval for the population proportion? So if I'm looking at this and I say, okay, my sample was 120 out of 300. So then I say, well, what's that actually going to look like? So if I do this, and I take 120 divided by 300, then most likely I'm going to get 40% or 0.40. Okay, that is my p hat. So I'm going to make sure you know what that looks like here. This then is p with a hat over it. That's this number right here. P hat is 40%. That's just for the sample, though. And so based on the idea that these people were randomly chosen out of a population, I then say, what's my population confidence interval? So I go here to inferential statistics, one sample proportion. This was 120 out of 300. Generate my results, and I'm picking a 95% confidence interval. So here, p hat is 0.4. My confidence interval is from 0.345 to 455 approximately. Okay, so then that means p hat is between 0.345 here and 455 over here. What does that mean? That means I don't actually know what the population proportion is, but I am 95% sure that it's between these two numbers. So if somebody says, hey, how many people have seen soccer on YouTube? I would say, well, I can't tell you exactly, but I am 95% sure that it's somewhere between like 35 and 46%. Somewhere in there. Or 35 to 40, yeah, 35 to 46%. So it's like, okay, that gives me an idea. So then I'll know 20% would be below that and 50% would be above that. I don't know exactly what it is, but I know a range. I know an interval that I can have confidence that the population proportion, okay, that's what I didn't do. So now what I'm saying is that this is the population proportion. The population proportion is between those numbers. This was my p hat. This is the sample proportion, is 40%. But now the population proportion is between these numbers. So I'm doing what I want to do. I want to find the population proportion number, even though I just have a sample. All right, so that's how to find the confidence interval for a proportion.